terms of all the bench testing we've got then, we've got a lot of data. Why do we still need to run field trials when we've got all this data from that bench testing?
So what you've got to consider about those bench tests is that they are targeted at different elements of performance. So what we have to do is view those tests as a whole, and gradually we'll reduce that number so we come down the funnel till eventually we've probably got 2 or 3 of those samples that we think can go on to the next stage. And the next stage is the more expensive stage of engine testing. And that's where we're going to put those samples into an engine, run them against a known reference test, and then we'll evaluate the performance of those oils, and from that determine which candidate you're going to take forwards to the final ship trial.
So what's the difference between an engine test and a field trial test?
In the engine test that we run, we dismantle it, we clean it, we measure it, we photograph it. In the ship trials, the difference is that we run to the procedures of the OEMs. So we meet their specifications and their requirements.
Okay, so the bench testing doesn't give us the whole story, which is why then we need to do our own independent engine testing leading on to those ship trial tests as well.
That's right. So let me give you an example. If we cast our minds back to 2020, the International Maritime Organization implemented a global sulfur cap of 0.5%. Our development started 3 years before that, and at that time there was no 0.5% sulfur fuel available in the market for us to be able to test. So what we had to do was to make our own in the laboratory from a range of different fuels that we got from different trials, and we use those fuels then to evaluate the performance of the additive packages that we were designing in the current range of bench tests that we were using at that time. We went through that funnel approach and reduced the number of candidate lubricants to 2 or 3, and eventually decided on 2 of those oils that we would put into a stationary engine to run the test. What surprised us was that what we saw from the engine test was different in some respects to what we'd seen in the bench testing. So we knew then that actually the bench testing that we were using at that time was not giving us the formulating direction that we needed for these new fuels. That was good. That helped us to redesign the bench tests so that we had correlation with what we saw coming out of the engine. So we introduced and we modified new or existing bench tests that gave us that confidence in the candidate formulations that we were developing, that they would work in the engine.
Okay, so bench tests then, they've proven to be pretty effective and reliable when we're testing against known conditions and known requirements. But when those conditions and requirements change, they're not as effective. So that's when we need to start focusing more on confirming the lubricant performance against engine tests or ship trials.
Yeah, and that's why we use a stationary engine test. Again, it's in controlled conditions, but that allows us to evaluate the performance of those lubricants prior to selecting the one that we put into a real-world ship trial. Ship trials are a longer duration. They're run in accordance with the engine designer's procedures. They're run under real-world operational conditions. Whilst all that's happening, what we've got to remember is that new engine designs are being introduced, new materials are being introduced, and if we look forwards just a few more years, there'll be new fuels entering the market. So those procedures are continually evolving, and it's the best place to test the performance of the lubricant.